I was building that 48-volt lithium battery, right? And I was using a voltmeter to get a measurement. But I used the cable that is actually used to be used for a power supply. It does not have an insulation at the connectors. So when I unplugged it from the multimeter, the two ends attached while being connected to a 48-volt battery that serves up to 10 kilowatts of power. So it basically sublimated the metal, which created a metal powder surface on my finger. When I entered the ER, they actually thought that it was a burning, which it wasn't. So in the end, it was actually not that bad. So I still do build those batteries. So. All right, today I'm sharing a little bit of our research we are doing, as part of our efforts to build Kubernetes-based operators to run data services. So a few words about myself. I'm Julian Fischer, and I'm running a company called Any9s. We are building cloud development platforms with a strong focus on data service automation. We've been automating data services for nearly 10 years based on virtual machines across infrastructures at scale, as well as now, obviously, on Kubernetes, natively using pods. Don't want to bore you with that shameless self-advertisement, so let's get to it. Primary goal here is today, so when I talk about an operator, I'm not talking about an operator that operates a single database. We are mostly seeing situations where companies want to create hundreds or thousands of databases, so automating the life cycle to operate those standard database use cases. It's not about that special case where you really need custom stuff. It's that is the general attitude we have towards automation. Now, with an intercluster instance, this is a bit different because whenever you want to stretch a Postgres database across infrastructure regions, across multiple Kubernetes clusters in this case, I think we are looking at a more custom use case because those inter-region Postgres scenarios, they require a bit of knowledge about the application. Otherwise, the latency can become problematic quite easily. So we are sticking to the conceptual level a bit. If you remind a few talks I gave earlier at the DOK, one of which was how to create a asynchronous streaming replication cluster on Postgres, where we basically created a stateful set within a headless service. No failover, anything fancy, just setting up the streaming replication. So that's a bit of the idea of the local cluster, just to understand the topology. If you would like to be reminded how this works, at learn-any9s.kubernetes.com, there's a tutorial on how to do that. You can follow through. I'm giving a lecture about this at a local University of Applied Sciences. So if you have time and you want to look into that, it's a good predecessor to revisit the talk here. So we are assuming there's a local container image. You could use the official Postgres, or we are using for building our operator the Patroni cluster manager, which comes with its own container image. Usually you define a headless service to be able to address the individual pods using DNS entries that will be maintained for you, and of course a stateful set. Configuration values you can keep in a config map, and your credentials and a secret. So far, standard stuff. Now, what if we take that and want to stretch that across multiple Kubernetes clusters? So our first assumption was, well, we just take one cluster, assume that this cluster will run a stateful set each with a replica of one. So there will be one pod per cluster. Here in this example, 3 clusters, 3 pods. And how can we connect them in order to form a Postgres cluster? Now, the gist of this talk, and that would be the main takeaway, would be it all boils down to the question, how can you do the network connection across those Kubernetes clusters? So pod-to-pod communication across cluster boundaries is basically the thing we are researching. And I I mean, it was a time constraints research, so we digged up two ways that appeared to be feasible. One would be Istio, and the other would be Cilium. I'll go into greater details into Cilium because Istio didn't turn out to be as simple to set up. So we got two engineers, they got the same time frame, and one got to manage a working solution based on Cilium, and the other got stuck with Istio. Doesn't mean that Istio is bad or shouldn't be considered, but it's just hasn't worked out in the same time frame. So this may tell a story, or maybe up to the individual, I don't know, performance of the engineers. Now, one of the takeaways when looking at Istio is that at least the way it was set up in our experiments was that Istio uses a sidecar. So basically, whenever you create a service instance, there will be another container in your pod that runs a gateway. You will talk to that sidecar container in order to get multi-cluster communication, which has some drawbacks. And two stick out. One would be this is not available during the pod initialization. So if you do something in init containers that require multi-cluster communication, this could be a constraint. And the other would be the sidecar container obviously requires a bit of resources. And if you do that like many times, which I don't think is really the case with intercluster service instances, however, if you do that many times, the overhead will multiply. So that being said, there are ways to combine Cilium and Istio. I think there are also ways with Istio that do not require a sidecar. So all of that you'd have to research a bit closer in your particular context. So one takeaway from looking at how to automate a data service across multiple Kubernetes clusters was also, well, you don't have the advantage of stateful sets if you have multiple clusters. So for example, ordinality and stable network identity is something you'd have to take care of yourself. And whatever automation you have that's, assuming there's a stateful set or the constraints of the stateful sets to be there, it cannot be just transferred to the multi-cluster scenario right away. I don't think it's a big issue, but still, it would be nice. Maybe you could even create, a controller that imitates the stateful set, but in a distributed way, using a state replication mechanism that provides you with sufficient consistency guarantees. So, all right. So this just shows that there is a pod container in the pod that gives you a gateway. In the example that we've been experimenting with, we are using that Patroni-based approach. If you're familiar with Patroni a bit, then you know that if you try to do leader election in Postgres, you need somehow to ensure that there are not two masters at the same time if you're using asynchronous replication. So there's a primary, that's the modern terminology, I think, and there are two secondaries. For example, you don't want two application instances writing to two different primaries. So etcd here provides guarantees that you can ensure that only one of the primaries can be, one of the nodes can be a primary at the same time. So in the intercluster example, we just took an etcd and stretched it across the same nodes. So in this case, two clusters, but you get the idea. And then configure Patroni to use that etcd cluster as its distributed configuration store. Now, going down the path with Cilium, same approach, but using Cilium, the conclusion was, or the observation was that it's not using a sidecar. Everything happens at the Kubernetes node level, where there's a Cilium agent using a technology called eBPF, I think, which is basically like a bytecode injection into the Linux kernel. It's really fast. So it's much faster than IP tables, for example, at scale. And very nicely, once you've configured Cilium, it's transparent, which means you can have multi-cluster communication through a service. So you'll create a service with a special annotation, and you do that across all the three clusters, and you have multi-cluster communication. From there on, it's basically building, that stateful set-like experience using pods and services. As of today, Cilium is supported across major platform providers, so you can basically get it for Amazon, Google Cloud Platform, whatever. If you're in an on-premise scenario, it's worth checking whether whatever Kubernetes flavor you're using provides, a Cilium for it, and whether it's compatible with your networking. But I'm positive that it'll work somehow. So yeah, I think there's not enough time to go into the Cilium details, but it's worth mentioning that it uses that eBPF approach, which is rather interesting. So in the end, you have a similar setup. You'd have 2 or multiple clusters, and you'd have the pods where the service instance run alongside with this etcd, and they would be communicating to other pods in the other clusters using a service. So it's actually a very neat thing that worked out of the box without too much hassle in a very time-constrained experiment. So I personally think it's, from the technical perspective, not really a big problem to get this up and running. It's more an interesting question, what are exactly the use case scenarios for this? Because, for example, asynchronous streaming replication with, let's say, Germany, Europe, and Asia will create large replication lags, and whenever you do a switch over, you'd have a serious risk for data loss. So, for example, this would be applicable in a situation where you have very little writes and many reads, and strict consistency is not a big issue. So they've also, the research put together a bit of a comparison. I will spare you reading that to you now. To me, the takeaways were that Cilium was easier to set up. It doesn't use a sidecar, or doesn't force you to use a sidecar approach. However, it requires you to have a certain degree of control over the Kubernetes cluster. So if you have a Kubernetes cluster as a given thing, and you cannot modify it, then you may not be able to use Cilium, which appears to be not really the case. Most of the Kubernetes distros will give you the ability to create a Cilium installation. However, I'm not ranting about Istio in any way. I think it's also worth having a look. But if using the sidecar approach, keep in mind there will be some additional resources. All right, conclusions are pretty simple. I think it's feasible. The experiment shows that there's a straightforward thing to do. The applicability is one of the things you want to look at. And yeah, that idea with distributed stateful set is something I'll take as homework, because maybe somebody already did that and I don't know of. Definitely worth looking into. As I said, if you're interested in how to set up Postgres manually, not to build a production-grade solution, but just to know how how the streaming replication works and so on, there's a tutorial here for free. There's also video recording of that, so if you want to do that, would be a way to go. There's a little demo on how the experiment basically works. We sped up the entire process. It basically creates 2 kind clusters or 3 kind clusters on a local computer, installs Cilium, and once these are created, we manually create a record in the current primary and ensure that it is replicated to the secondary. So that's basically the visual showing you that we can replicate data across cluster boundaries with the concept I just showed you. So from the effort perspective, I can tell this wasn't, weeks or months, well, weeks maybe, but not months of work. Also, that wasn't their primary objective during that time. So as I said, it's pretty much a straightforward thing to do. We keep you updated with whenever we touch that topic again, may come up with additional updates in subsequent talks. Feel free to reach out if you have demand for this and would be curious to see this implemented somewhere. We are always looking for use case scenarios that we could learn from. All right, let me see. video's been, I think, over. If there are any questions at this point, just feel free to ask. Otherwise, well, thanks a lot for your attention. Hopefully that was worth the time.
We've got a question. And is it or is it not pizza related?
It's difficult. It's about MySQL. No, just kidding. Now, how does the backup fit in that architecture?
Well, backups you'd usually create from a primary in such a situation because that would be the one that's mostly up to date. And the backup in our operator, for example, would be declared. So you'd have CRD to declare a backup. It's basically a local backup. Whether you want to replicate a backup across regions would be something interesting.
Yeah, mine is more about using as a fallback the actual object store backups, for example, WAL files, in case the network communication goes down temporarily on the other side. That was just, if
I mean,
that
you
could
mean
be
what
an
if
option.
one region goes down and what happens then? Is that the
No, if the network communication maybe temporarily goes down, you could use the object stores. The WAL files that are stored in the object store as a temporary, as a fallback mechanism. So I was wondering if you had planned the backups in that scenario or not.
No, I don't think it uses the backups for that scenario.
Okay.
Well, you could make the operator do something like that, but one of the interesting questions would be, how do you get a backup, globally distributed, where you could try to access, the object store where backups are stored, but if the entire region is, out of order, you need to replicate those objects from the object store as well somehow, which I think most cloud providers can do.
Yeah, exactly. I mean, there's several, maybe.
Yeah, interesting thought though. Thanks.
Yeah, no worries. Thank you.